Just like with differentiation, at the start, you took down the rules, right? The ones that you needed to differentiate trig. For integration, exactly the same. I want you to have these written down, and then you can refer to them when you're doing questions. The more questions you do, the more second nature is going to feel. You won't have to use your cheat sheet to refer from. Once you've got that down, let me take you through 2 questions or 3 questions, and then you're going to try some completely on your own. Okay, so let me start with part A. When you are integrating, you always want your term in terms of powers, right? So let's say if you have 1 over x squared, you want to convert that into something like that, x to the power of minus 2. You don't want any fractions, you don't want any surds, you want to convert them using your indices rules, and you want to simplify as much as possible before you even integrate. Okay, when you're integrating something like part A, you're going to do each term separately. So, how would you integrate 2 cos x? In something like this, you can write it, so integral of 2 cos x, you can write this as 2 integral cos x. Okay? Now, how would you integrate cos x? Using this rule, it turns into sin x. So, you would have 2 bracket sin x, so 2 sin x. Now, for 3 over x, you can write it as 3 integral 1 over x. Yeah? There's a rule for 1 over x, ln x. So this becomes, let's do equals. This becomes 3 bracket ln modulus of x. So 3 ln x. The last one, root x is the same as x to the power of a half. You add 1 to the power, you then divide by that power, so you get 2 over 3 x to the power of 3 over 2. All you have to do now is put them all together, making use or being mindful of the operations between each term. So 2 sin x plus, because there's a plus there, 3 ln x minus 2 over 3x to the power of 3 over 2 plus c, because you have no intervals. Did that make sense? So you're going to do each one separately, then you're going to put it all together. Okay, let me move this here for now, and let's do B. For B, your first term, your fraction, is a little complicated. Can you try and simplify so that you don't have a fraction anymore? You have an equivalent term which, has no fraction. So if you split the fraction into something like this, what's cos x over sin x equal to? Cot x. And what's 1 over sine equal to? Cosec. Cosec x. Okay? So, is there a way for you to integrate cot x cosec x? Let's have a look. Yep, there you go. That's the rule. When you integrate that, you get minus cosec. Okay, so minus 2e to the power of x. So you get minus cosec x, and then minus 2e to the power of x plus c. Because remember, you can make this 2 integral e to the x, and e to the x integrated is just e to the x. 2 bracket e to the x, 2ex. There you go. That is that integrated. Right. Let's have a look at another scenario. Something like this. Now you have your intervals and you have a fraction. In something like this, you want to first simplify that fraction. 3a and a, 2x over x plus 1 over x dx. If you didn't know, that dx just means with respect to x. Okay. This would then simplify to just 2 plus 1 over x dx. What would you get when you integrated 2? 2x. What do you get when you integrate 1 over x? Ln x. And now 3a and a. Now you just have to substitute in. So 2 times 3a is 6a plus ln 3a minus 2 times a, 2a minus ln a. Cool? So that means 4a equals 4a minus ln 3a over a, 4a minus ln 3. This is equal to ln 12, which they told you in the question here. Now that we've got our simplified integral, now we can solve. 4a equals ln 12 plus plus here, ln 12 minus ln 3. 4a equals ln 4, a equals ln 4 all over 4. That's your answer. Okay. Have a look at this question. You've got D and F. Can you try both of those for me, please? For D, you would ideally want to simplify 1 over sine squared. How can you simplify 1 over sine squared? What is that the same as? Cosec squared plus 1 over x. Is there a way or is there a rule for cosec squared? Yes, there is right here. So, minus cot x plus ln x plus c. Done. That's it. That's that integrated. For f, again, you want to simplify. So let's expand the bracket. All with respect to dx, and same with this one. And now, from here, you want to now simplify this part. So cosec squared is the same as 1 over sine squared times cos x. So 1 over sine x times cos over sine x. These two are equivalent, right? So 1 over sine is cosec x, and cos over sine is cot. So that means cos x plus cosec x cot x dx. Now I have it in terms where I can find the integral, or I can integrate. I don't have a rule for cosec squared cos, nor do I have a rule for 1 plus cosec squared. So by simplifying, or by finding equivalence, I can now put it in a form that I can integrate. Integrating cos gives sine. Integrating cot cosec gives minus cosec plus c. That's making use of that blue rule here. Okay? Cool. Question 4. Give that one a go for me, please. So this one is very, very similar to the previous one, the one that we went over, 2x plus 1 over x. In this case, you've got 3x over x minus 1 over x. 2a and a are your intervals, all with respect to dx. This is going to simplify to 3 minus 1 over x dx. When you integrate this, you get 3x minus ln x, 2a and a. Let's plug it in first. So 6a minus ln 2a minus 3a minus ln a. Okay, now 6a minus 3a is 3a. Minus ln 2a minus ln a is the same as minus ln 2a plus ln a. So 3a minus ln 2 plus ln a plus ln a. So I've used my log rules to split ln 2a. Now, if I expand, I get this, which means 3a minus ln 2. The benefit of doing that, or the reason to do that, is to eliminate the ln a. Okay, now, this is the same as ln 2 to the power of minus 1. Let's imagine there's a minus 1 here. So again, using the log rules. So that means 3a plus ln 1 over 2. And that is all equal this. So let's move the equals here. 6 plus ln half. Which means a equals 2. Because these two terms are the same and these two terms are the same. A has to equal 2 in order for the two sides to be the same. Okay, so that is the start of integration, and in the case of this question, a good amount of logs as well.